Have you ever wondered why you skid on a wet floor? Why a stationary car begins to move when you push it? Or why you feel a jerk when a bus starts moving or stops? These everyday experiences are all governed by a set of principles we call Newton's laws of motion. Named after the renowned physicist Sir Isaac Newton, these laws describe how objects behave when they're in motion, at rest, or under the influence of external forces. They're fundamental to our understanding of the physical world, and they're simpler than you might think. Newton's first law of motion, also known as the law of inertia, states that an object will stay at rest or keep moving in a straight line at a constant speed unless acted upon by an external force. It's the reason why you need to push a stationary car to get it moving, and why you keep moving forward when the bus you're on suddenly stops. It's all about resistance to change in motion. Next up is Newton's second law of motion, which explains the relationship between an object's mass, its acceleration, and the force applied to it. It's often expressed as the equation F equals sine ma, where F is the force, m is the mass, and a is the acceleration. This law tells us that the force required to accelerate an object is directly proportional to its mass and the acceleration. So, the heavier the object or the faster you want it to accelerate, the more force you'll need. Finally, Newton's third law of motion postulates that for every action, there is an equal and opposite reaction. This means that any force exerted on a body will create a force of equal magnitude but in the opposite direction on the object that exerted the first force. Think about it this way. When you jump off a boat, the force you exert to push off propels the boat backward. That's Newton's third law in action. To summarize, Newton's laws of motion are three principles that describe the relationship between a body and the forces acting upon it, and its motion in response to those forces. The first law, the law of inertia, states that an object will stay at rest or keep moving at a constant speed in a straight line unless acted upon by an external force. The second law defines the relationship between an object's mass, its acceleration, and the force applied. And the third law asserts that every action has an equal and opposite reaction. Understanding these laws can provide a new lens to view and interpret the world around us, from the slip on a wet floor to the push of a car, from the jerk in a bus to the recoil of a boat. These are not just abstract physics principles, but everyday realities guided by the genius of Newton's laws of motion.